The new topic today is simultaneous equations with curved lines. Um, so remember, so this is a more advanced version of simultaneous equations. A recent video I have about simultaneous equations, but that's all about two linear lines. But here we're going to be solving simultaneous equations with some curved lines. So remember, the definition of simultaneous means more than one. There's more than one equation. And one or both of these equations might have a curved line. So let's look at this question over here. X squared plus y squared equals 13. X equals y minus 5. And we have to solve the simultaneous equations. Well, there's two equations, and there's two unknowns. This is a perfect simultaneous equation. Now, do you spot any curved lines in either of these equations? Well, here's a little trick to see if you have a curved line. If you have any squared values, okay? So the top value is x squared plus y squared is equal to 13. You don't have to know this, guys, but this graph is going to look like a circle, actually, the first equation. But all you need to know is that since there's a squared graph, since there's a square, this is definitely a curved line, okay? So we have a curved line, it's a circle, and this is just a linear line, because you can rearrange it to y equals mx plus c. We can plus 5 on both sides. So it's x plus 5 equals y, or just y is equal to x plus 5. This is just a straight line. And we're solving the simultaneous equations. Basically, we're trying to find out where these two lines, the coordinates at which these two lines intercept. So whenever you're solving a simultaneous equation with curved lines, you must use the substitution method, okay? We can never use, maybe you can, but I solve it using substitution method. So how do we do this? What you want to do first, guys, is you want to look at the linear line, so the second equation, and think to yourself, what's bigger? Is x bigger or is y minus 5 bigger? Well, that was a trick question because they're both equal to each other. X is exactly the same as y minus 5. So if we were to write down our curved line, x squared plus y squared equals 13, I can replace x with y minus 5 because x is equal to y minus 5. So instead of x squared, we're going to do y minus 5 squared plus y squared is equal to 13. Next, we have one equation and there's only a single variable. So we can solve this. Let's solve this by first expanding the brackets. So we'll expand y minus 5 squared. So y minus 5, y minus 5. First, y times y is y squared. Outside the outer terms, y times minus 5 is minus 5y. Inner terms, minus 5 times y is minus 5y. And last terms, minus 5 times minus 5 is positive 25. We'll combine the like terms, so minus 5y minus 5y makes y squared minus 10y plus 25. So if we were to expand y minus 5 squared, it'll be y squared plus 10y plus 25 plus y squared equals 13. Next, we can combine the like terms again. So y squared plus y squared, well, that's y squared, is 2y squared minus 10y plus 25 equals 13. We have a quadratic. I have a squared term, a single letter term, and a constant. So whenever we have to solve some sort of quadratic, make sure the other side is 0. So we'll subtract 13 on both sides. So we have 2y squared minus 10y plus 25 minus 13 is positive 12 equals 0. Oh, look, I can also factorize out the 2 from each term. We can divide all terms by 2. So it'll be 2y squared minus 5y plus 6 equals 0. And inside we can solve by factorizing. A, B, C. A, y squared is 1y squared. B is negative 5. C is 6. we find two numbers that multiply to 6 and add to 5. So what plus what adds to negative 5, and what times what multiplies to 6? Negative 3 and negative 2 multiply to 6, and negative 3 plus negative 2 add to negative 5. So our answer for our factorization is going to be x minus 3 and x minus 2 is equal to 0. X minus 3 equals 0. X must be 3. 3 minus 3 equals 0. And x minus 2 is 0. X must be 2 because 2 minus 2 equals 0. So these are our two x values. Now, how do you find the y values? Same as before. You're going to plug your two x values back into either of the equations. Clearly, the second equation seems much easier. Let's go ahead and find our y values. So x is equal to y minus 5, and x is 3. So I'll replace x with 3. 3 is equal to y minus 5. What minus 5 is 3? Well, that's just 8. Y must be 8. So our first answer is when x is 3, y is 8. And then our second value for y, we'll do it again. So x minus y is 5. X equals y minus 5. I'll replace x with 2. So 2 equals y minus 5. Something minus 5 is 2. Y must be 7. So when x is 2, y is 7. So basically, guys, the points at which these two lines intercept is this coordinate will be 3, 8, and this point will be 2, 7. So these are our two answers. X equals 3, y equals 8, and x equals 2, y equals 7. Solve the simultaneous equations. X squared plus y squared is 41. Y equals 2x minus 3. So this is an advanced simultaneous equation because the first equation is a curved line. X squared plus y squared is always a circle. So we're going to have to use a substitution method like we did earlier. So we'll look at our linear equation. Y equals 2x minus 3. So y is exactly the same as 2x minus 3. So write down our our curved line. X squared plus y squared equals 41. And we can replace y with 2x minus 3. So I'll replace this y with 2x minus 3 because they're equal to each other. So what do we have? We have x squared plus 2x minus 3 squared equals 41. Here I have some brackets. Let's expand that. So let's do it over here. 2x minus 3 times 2x minus 3. First, 2x times 2x is 4x squared. Outside, 2x times negative 3 is negative 6x. Inside, minus 3 times 2x is negative 6x. And last, minus 3 times minus 3 is positive 9. And that can be simplified to 4x squared. Minus 6x is minus 12x plus 9. So let's write that down back here. So x squared plus 4x squared minus 12x plus 9 equals 41. Let's simplify the like terms. X squared plus 4x squared is 5x squared minus 12x plus 9 equals 41. Ooh, this is a quadratic. There's a squared term, a single x term, and a constant. So we have to make sure the other side is always equal to 0, so we're going to minus 41 on both sides. So we have 5x squared minus 12x plus positive 9 minus 41 is negative 32, I think. Yes, equals 0. And then we can solve this by factorizing. Any common factors between these three terms? Nope. So let's just go straight into our quadratic factorization. So a, B, C. A is 5x squared, B is negative 12, and C is negative 32. Remember, when A is not 1, it's going to be a little bit harder. So we have to add to B always, so we're going to add to negative 12. But we're going to multiply to A times C. So 5 times negative 32 is negative 160. So what two numbers add to negative 12 but multiply to negative 160? This will take a little bit of time. What do we have? What numbers multiply to 160? 1 times 160, 2 times 80, 4 times 40, 5 times 32, 8 times 20. Oh yes, 8 times 20. So negative 20 times 8 makes negative 160, and negative 20 plus 8 makes negative 12. So now we can factorize. Oh no. Now since this is hard quadratic, we have to split the b term. So remember guys, in order to solve this problem, you have to know how to factorize, okay? Let's write down our quadratic, 5x squared minus 12x minus 32. So our a value stays the same. Our b value gets split up into our two new values, negative 20 and positive 8. So negative 20x, positive 8x, or you can do positive 8x, negative 20x, minus 32. Watch my video on factorization if you want to double check how to solve hard quadratics. Then you're going to cut the 4 terms in half, then factorize both sides using common factors. So for the first side, it'll be 5x, x minus 4. Second side, what's in common? 4. Oh no, sorry. 8's the highest common factor. X, 8 times 8 to negative 32 is times by negative 4. Ooh, great. Both terms in the brackets are the same. So our first bracket will be x minus 4. And our second bracket will be 5x and positive 8. So then we can solve for x. Well, first bracket's easy. So first bracket will be x minus 4 is 0. Well, x must be 4. 4 minus 4 is 0. Our second bracket's a little bit harder. I'm going to write it out and solve it. So 5x plus 8 equals 0. I'll subtract 8 on both sides. So 5x equals negative 8. And then divide 5, divide 5. X is equal to negative 8 over 5. X is equal to, basically that is negative 1.6. Those are our two values for x. Now, how do we find our values for y? Pretty straightforward. We're going to plug in our x values back into either of these equations. I like to put it always into the linear graph because it's much easier. So y equals 2x minus 3. We'll replace x with 4. So y is equal to 2 times 4 minus 3. So y equals 2 times 4 is 8, minus 3 is 5. So our first answer is when x equals 4, y equals negative 5. And our second answer, y equals 2x minus 3. We'll replace x with minus 1.6. So y is equal to 2 times negative 1.6 minus 3. Y is equal to 2 times negative 1.6 is negative 3.2. Minus 3 is negative 6.2. So when x is negative 1.6, y is going to be negative 6.2. And those are your two answers. So if we were to do a diagram, this first graph is a circle, the second graph is a straight line, and the 2 points that they intercept are, the first one is 4, 5, and the second intersection is negative 1.6 and negative 6.2. And that's how you do it. Same as before, guys. Question, Solve the simultaneous equations. Give your answers to three significant figures. X squared plus y squared is 20. 2x plus y is 3. Okay, so we have two equations, therefore it's a simultaneous equation. And the first equation is a curved line, because I see some squares. All right, so what we can do is we can get our linear line and somehow plug our either the x and the y into our curved line. Before we do that, we have to make either x or y the subject. In the previous questions, y was ready by itself, so y was the subject. In the question before that, x was by itself, so we could easily plug in the other side. So for this question, guys, make sure you first rearrange the equation to make x or y the subject, so you can plug it into the first equation. So let's maybe make y the subject first, okay? So let's get y by itself. So y is being added by 2x, so we can minus 2x. So that cancels out. Y is equal to 3 minus 2x. If you want, you can make x the subject. Let's have a look. 2x plus y equals 3. We'll get x by itself, so we're going to minus y on both sides. That cancels out. 2x is equal to 3 minus y. X is being multiplied by 2, so we're going to divide by 2. Boom. X is equal to 3 minus y over 2. Now choose carefully, guys. Which one of these expressions is better? I think it's better when y is the subject, because there's no fraction, okay? Try and avoid fractions, so we don't want to use that. So we're going to use y equals 3 minus 2x. So just make sure you make x or y the subject if it's not already. So y equals 3 minus 2x. So now we can get our curved line, which is basically a circle. X squared plus y squared is 20. Since y is exactly the same as 3 minus 2x, we can replace this y with 3 minus 2x. Let's go ahead and write out a new equation. So x squared plus 3 minus 2x squared equals 20. Ooh, I see some brackets. Let's expand the brackets. We'll do it up here. 3 minus 2x times 3 minus 2x. First, 3 times 3 is 9. Outside, 3 times negative 2x is negative 6x. Inside, negative 2x times 3 is negative 6x. Last, minus 2x times minus 2x is positive 4x squared. Let's combine the like terms, and I'll put the 4x squared in front, so 4x squared. Minus 6x is minus 12x plus 9. So we have x squared plus 4x squared minus 12x plus 9 equals 20. Let's combine the like terms. X squared plus 4x squared is 5x squared minus 12x plus 9 equals 20. This is a quadratic. There's a square term, an x term, and a constant. So the other side has to be equal to 0. So we're going to minus 20 on both sides. So we have 5x squared minus 12x plus 9 minus 20 is minus 11 equals 0. Let's group this all together. Now, let's erase all this. Have a look at the top. Give your answer to 3 significant figures. This is really important. If you're ever given a quadratic, in this case our quadratic is, I'll write it nice and big on top, 5x squared minus 12x minus 11 equals 0. If you're ever given a quadratic and you're asked to give it to 3 significant figures or any number of significant figures or decimal places, you cannot factorize it using quadratic factorization. In order to solve this quadratic, you have to use the quadratic formula. that's a little clue. If you're ever given a quadratic where it's asking you to give your answer to significant figures or decimal places, you must use the quadratic formula, which is in your formula sheet, which is minus b plus or minus the square root of b squared minus 4ac over 2a. Let's go ahead and fill it out. Well, let's write down our a, b, and c value. Our a value is 5x squared. Our b value is negative 12. And our c value is negative 11. So let's go ahead and plug this into our quadratic formula. So minus b is negative 12, plus or minus, we'll do plus first, the square root of b, so negative 12 squared minus, I like to put 4ac in brackets, minus 4 times 5 times negative 11 over 2a, so 2 times 5. That's it. Just throw it into your quadratic formula. Negative 12 plus the square root of negative 12 squared minus 4 times 5 times negative 11 over 2 times 5. So our first answer for x is going to be 3 significant figures. So 3.10787. 1, 2, 3. So we have to round it to the 2 decimal places. So 3.11 is our first value for x. How about our second value of x? Instead of the plus, we'll replace it with a minus. All right. Is negative 0.7078. Round to 3 significant figures. Well, 1, 2, 3. We're going to round it to this number. So 8, we round up. So 0.708. So those are our 2 x values, guys. X is equal to 3.11. X is equal also to, negative 0.008. And then to find our y value, we plug our x value back into this equation. So the y coordinate is equal to 3 minus 2 times x. Well, we'll say x is 3.11, so y is equal to 3 minus 2 times 3.11. See what our answer is there. 3 minus 2 times 3.11. Negative 3.22. So that's our first answer. When x equals 3.11, y is equal to negative 3.22. And then our second value for y can be found by plugging this this value back into our equation. So it's going to be y is equal to 3 minus 2 times negative 0.708. Y is equal to 3 minus 2 times negative 4.416. And these are our second set of values. So 1 answer and 2 answers. Next question. Solve the simultaneous equations y equals 2x squared, y equals 20 minus 3x. Show clear algebraic working. Well, I noticed something here, guys. Y is equal to 2x squared. Let's write that down. And y is also equal to 20 minus 3x. So if y is the same as 2x squared, and y is also the same as 3 minus 2x, then what's the relationship between 2x squared and 20 minus 3x? Well, they must be equal to each other because they're both equal to y. So we can say, okay, 2x squared must be equal to 20 minus 3x. So this one's actually a very easy question because both equations had y as the subject, so both expressions are going to be equal to each other. Then we can just rearrange it. Because I see a squared term, an x term, and a number term, this is going to be a quadratic. So you have to spot that. So that's plus 3x on both sides, plus 3x. So it's going to be 2x squared plus 3x equals, that cancels out, 20. And then we're going to minus 20 on both sides. So 2x squared plus 3x minus 20 equals 0. So it's important, guys, when you're at this point here, you can spot the quadratic before it looks like a proper quadratic. You have to spot the squared term, the x term, and the number term, and rearrange it so they're all on the same side and the other side is 0. And then this is a quadratic, so we can solve it by quadratic factorization, or we can solve it using the quadratic formula. I'm going to solve it by quadratic factorization. First, there's nothing in common between these three terms, so let's just jump straight into it. So our a term is 2x squared, our b term is 3x, our c term is negative 20. A is not 1. This is going to be a little bit harder. So always we add to b, so we're going to add to 3, and we're going to multiply to a times c. So what's that going to be? 2 times negative 20 is negative 40. So we have to find two numbers that add to 3 and multiply to negative 40. That's pretty straightforward. Negative 5 and 8. Negative 5 and 8. So now I'll rewrite our quadratic. 2x squared plus 3x minus 20. And we're going to split the b term. So our a term stays the same, 2x squared. Our b term gets split up into negative 5x and positive 8x. And our c term stays the same. And we'll cut it in half. And we'll factorize both sides using common factors. What's in common between 2x squared and minus 5x is an x. Open up a bracket. X to 2x squared is 2x. X to negative 5x is negative 5. Next pair, the highest common factor is 4. That's it. So 2x minus 5. Ooh, great. Both terms in the brackets are exactly the same. So we've done it correctly. So our first bracket will be 2x minus 5. Our second bracket will be x and positive 4 equals 0. Something plus 4 equals 0. Well, x must be negative 4. Negative 4 plus 4 is 0. So that's our first value for x. Pretty easy. Our second value for x, 2x minus 5 equals 0. Let's write that out. That's going to be a bit harder. 2x minus 5 equals 0. And we're going to solve this. So x is being multiplied by 2, then subtracted by 5. So we're going to add 5 on both sides. So 2x is equal to 5. And then 2 times what is 5? 2 times 2.5. X is 2.5. So those are the two values for x. X is 4. Negative 4. And x is equal to 2.5. Now, how do we find our y value? It's pretty straightforward. You can plug your x values into either of these equations. I'll plug it into the first equation. That seems pretty straightforward. Y is equal to 2x squared. So y is equal to 2. Instead of x, I'll replace it with negative 4 squared. Y is equal to BIDMAS, so you do the square first. Negative 4 squared is 16 times 2 is 32. So when x is, so our first answer is x equals negative 4, y equals 32. And then let's do our next value of x. I'll plug it into the first equation as well. Y equals 2x squared. Y is equal to 2 times 2.5 squared. 2.5 squared is 6.25 times 2 is 12.5. And those are our other two coordinates. So basically, guys, so those are our answers, and let me just draw a little sketch to illustrate this problem. The first graph is a squared graph, so it's going to be and since it's positive 2x squared, that graph's going to be a U shape. And our second graph is a linear graph, and since it's negative 3x, our gradient is going to be negative. We're basically, whenever we're solving a simultaneous equation, we're just finding out where these two lines intercept. So we're doing something at these 2 points. So this coordinate here must be negative 4, 32. And this coordinate here must be 2.5 and 12.5. And that's just our answer illustrated, okay? Which we'll need to understand in the next question. The next two questions we're going to be looking at are board problems. This question is definitely like an A-star level question, and the question we'll do next is like an A-star level question, okay? Let's look at this question first. This sketch shows the curve of the equation of y equals x squared plus 4 and the line with equation y equals x plus 10. Yeah, we have a curve, x squared plus 4, and then y equals x plus 10. Fantastic. The line cuts the curve at points A and B. Yeah, these are the points where the two lines intersect each other. M is the midpoint, so M is directly in the middle of A and B. Find the coordinates of M. So we have to find what M is. That's our goal. Okay? So if I'm doing this question, I'm like, I gotta find the midpoint. Maybe I should find points A and B first. And once I'm able to find points A and B, I can just take the averages of the x coordinates and then take the averages of the y coordinates to find the midpoint. So how do we find points A and B? Well, A and B are basically the intersections between the curved line and the straight line. If you're ever asked to find the intersections between two lines, all you have to do is set both equations equal to each other. So our first equation is y equals x squared plus 4. Our second equation is equal to y equals x plus 10. And we just have to solve this simultaneous equation. And here's what I noticed, guys. Both equations are equal to y. One sec. The first equation, x squared plus 4 is equal to y. And the second equation, x plus 10 is also equal to y. If both these expressions are equal to y, therefore they must be equal to each other. So we can say, okay, x squared plus 4 is equal to x plus 10 because they're both equal to y. And then, ooh, all right. I notice this is a quadratic. I see a squared term, an single x term, and I see some numbers. So remember, guys, quadratics always have to be equal to 0. So let's move all of these terms on the right-hand side to the left-hand side. So how to get rid of this x? We're going to subtract x. So it'll be x squared plus 4. If we minus x on this side, we minus x on this side. So minus x equals 10, because that cancels out. And to get rid of this 10, we're going to minus 10 on both sides. Minus 10, that cancels out. So x squared, I'll put the minus x in front. And then plus 4 minus 10 is minus 6 equals 0. And we've made a perfect quadratic. So we can solve this by factorizing or using the quadratic formula. I'll solve it by factorizing. So a, b, and c. So x squared is 1x squared, so a is 1. Minus x is minus 1x, so b is negative 1. And c is negative 6. So remember, guys, we have to find two numbers that multiply to c and add to b. So something plus something makes negative 1, and something times something makes negative 6. Well, here we go. Negative 3 times 2 makes negative 6, and negative 3 plus 2 makes negative 1. So these are the two values. So we can open up two brackets. Boom, boom, boom. X minus 3 and x positive 2 equals 0. So we'll grab one of the brackets only. So x minus 3, set it equal to 0. So what minus 3 is 0? X must be 3. And then here, x plus 2 equals 0. X must be, what plus 2 is 0? X must be minus 2. Minus 2 plus 2 is 0. So the two x coordinates of the intersections are 3 and negative 2. So this must be 3, and this must be negative 2. And then we got to find the y coordinates of each intersection. To do that, like before, you plug in the x values into either equation. I'll plug into this linear equation. So what do we have? Let's change color. So y equals x plus 10. And we're going to replace x with 3 for this coordinate. So y is equal to 3 plus 10. Y is equal to 13. So this point here has an x coordinate of 3 and a y coordinate of 13. So that's coordinate B. Coordinate B is equal to 3, 13. And then coordinate A, so y equals x plus 10. And I'll replace x with minus 2. So y is equal to minus 2 plus 10. Minus 2 plus 10 is positive 8. So we know this coordinate here is positive 8. So the A coordinate is negative 2, positive 8. Now, since we know point A and point B, we have to find the midpoint between point A and point B. Remember, guys, there's a little formula to find the midpoint. The midpoint is always equal to the average or the mean of x and the mean of y. So to find the x coordinate, we have to find the mean of the x coordinate. So let's find the mean of 3 and minus 2. To find the mean, we're going to add them up, 3 plus minus 2, and then divide them by two values. 3 plus minus 2, you can use your calculator, it'll give you 1. And you divide that by 2, so it's just going to be 1 over 2, which is going to be 0.5. And then to find the y coordinate of the midpoint, we're going to find the mean of the y values. So add those up, 13 plus 8, divide them by 2, equals 21 divided by 2 is 10.5. And that is the midpoint, 0.5, 10.5. And that is our answer for M. Last question. This one was a past paper question from one of my students. This is definitely a tough question, definitely like an A-star level question, and also on the harder end of an A-star level question, I feel. Let's just jump into it, and I think we'll find it's actually much easier than we'd expect it to be. The curve of equation x squared minus x plus y squared equals 10, and the straight line of equation x minus y equals minus 4 intersect at the points A and B. Work out the exact length of AB. Show you're working clearly and give your answer in the form root A over 2, where A is an integer. Okay, so we have a curve and a straight line which intersect. To be honest, guys, I have no idea what this curve looks like. But I'm going to say, let's just say it's a U shape. Doesn't really matter. It's probably wrong. I'm going to be out of a job soon. So we have a curve, which looks like this, and a straight line, which looks like this. I don't know. And they intersect at point A and B. Okay, let's label that A and B. Now, we're asked to find out the exact length of AB. Basically, guys, the goal of the question is to find the length from from this point here to this point here. That's our goal. Now, if we're asked to find that length, maybe the best way to start is by finding the coordinates of A and B. That'd be a good place to start. Let's find the coordinates of A and B first. So if we're trying to, and A and B are the intersections between the two lines. So the first things first is you should get both equations of lines and create a simultaneous equation out of them. So x squared minus x plus y squared equals 10. That's our curved line. And then our straight line is going to be x minus y equals minus 4. And we've created a simultaneous equation. Now we just want to solve it. So I've got my linear line. Let's rearrange it to make, let's make x the subject, okay? So if we make x the subject, we can plug it into our curved line. So let's get rid of this minus y by plussing y. Let's do the same thing to the other side. So minus y plus y cancels out. So we're left with x is equal to minus 4 plus y. All I'll just do, positive y minus 4. Now, let's get our curved line. Let's copy it out again. X squared minus x plus y squared equals 10. And then, instead of x, so since x is exactly the same as y minus 4, we can replace this x here and this x here with y minus 4. So instead of x squared, it'll be y minus 4 squared minus, instead of x here, it'll be y minus 4 plus y squared equals 10. All right, then I see some brackets. Best to expand that. Y minus 4 squared means y minus 4 times y minus 4. So let's expand the brackets up here. Y minus 4 times y minus 4. Y times y is y squared. First, outside terms, y times negative 4 is negative 4y. Inside terms, minus 4 times y is minus 4y. And last terms, minus 4 times minus 4 is positive 16. So if we combine the like terms, it'll be y squared minus 4y is minus 8y plus 16. So this whole thing gets simplified to y squared minus 8y plus 16. Then we'll expand this. Minus y minus minus 4, it will be positive 4 plus y squared equals 10. Let's keep on simplifying it. Y squared plus y squared is 2y squared. Minus 8y minus another y. Well, minus y means minus 1y. So minus 8 minus 1 is minus 9y. And then plus 16 plus 4 is positive 20 equals 10. Ooh, we've created a quadratic, a square term, a single y term, and a constant. But remember, in order to solve a quadratic, the other side has to be equal to 0. So we're going to minus 10 on both sides. Boom, boom. So it's just the same thing as before, guys. 2y squared minus 9y plus 10 positive 20 minus 10 is positive 10 equals 0. We've created this is our quadratic, it's equal to 0. Let's solve this. You can solve this by factorizing or the quadratic formula. I'm going to solve it by factorizing. Let's do it over here. So 2y squared minus 9y plus 10 equals 0. We'll write down our a, b, and c terms. A, b, c. A is 2. B is negative 9. C is 10. So since a is not 1, it's going to be the hard version. So we're going to add to b still. So we're going to add something plus something still adds to minus 9. But we're going to multiply to a times c. So we're going to multiply to 20. So you have to find two numbers that multiply to 20 and add to negative 9. That is negative 5 times negative 4. And negative 5 plus negative 4 makes negative 9. What we're going to do next is we're going to write out our quadratic again. A's term stays the same, 2y squared. But our b term gets split up into our two new b terms. So minus 5y minus 4y plus 10 equals 0. And we cut it in half because there's 4 terms. And we're going to factorize both sides using common factors. What's in common between 2y squared and minus 5y? A y is in common. So it's going to be 2y minus 5. And on the other side, what's in common between minus 4y and positive 10? Minus 2. How do you get from minus 2 to minus 4y? You have to multiply by 2y. How do you get from minus 2 to positive 10? We multiply by minus 5 equals to 0. So let's put this over here. So our first bracket will be 2y minus 5. Our second bracket will be a combination of the outside terms. So y minus 2 equals 0. Let's solve each one. 2y minus 5 equals 0. Let's write that down. 2y minus 5 equals 0. So plus 5 on both sides. 2y is equal to 0 plus 5 is 5. 2 times something is 5. We'll divide both sides by 2. Y equals 2.5. And then we'll do the same thing with this bracket here. So y minus 2 equals 0. This is pretty easy. What minus 2 makes 0? Y is 2. So we know the y coordinates of both these coordinates. This one here has a y coordinate of 2.5. This coordinate here has a y coordinate of 2. Now, how do we find the x coordinates? Well, like before, we plug the y coordinates into either of these equations. I'm going to plug it into this equation here. And earlier, I rearranged x minus y equals minus 4 into this equation here. X equals y minus 4. So let's use that one. That looks even easier. X equals y minus 4. So we'll replace y with 2.5. So x is equal to 2.5 minus 4. X is equal to minus 1.5. So when y is 2.5, x is negative 1.5. So this is minus 1.5. And then we'll do the same thing to the other coordinate. We'll plug 2 into this. So x is equal to 2 minus 4. X is equal to 2 minus 4 is minus 2. So these are the two coordinates, and we have to find the length between these two coordinates. I'm going to do this on the next page, guys. So let's draw our graph. Boom, boom. The top coordinate's minus 1.5, 2.5. The second coordinate is negative 2, 2. And we have to find the distance between these two coordinates. That's our goal. How do we do this? Well, whenever I'm asked to find the length of like some sort of diagonal line, I always think, let's make a triangle out of this and use Pythagoras. So what we're going to do is we're going to make a little triangle. All right? And if we're able to find this length here and this length here, we can use Pythagoras to find this length here. Pretty easy. Now, if you want to find the distance, the horizontal distance, let's change color. If you ever want to find the horizontal distance, you look at the difference in the x coordinates. How do you get from negative 2 to negative 1.5? What's the difference between those two numbers? Well, that's pretty easy. The difference is 0.5. And to find the height, you look at the difference in the y coordinates. What's the difference in the y coordinates from 2 to 2.5? It's also 0.5. So we can draw a triangle. Boom, boom, boom. We know this length is 0.5, which is 1/2. And we know this length here is 0.5, which is 1/2. I'm converting them into 1/2 because I see they want my answer as a fraction. So I'm converting my decimals into fractions. And we can just use Pythagoras. Because we have a right angle triangle, we have the a value, we have the b value, and we want to find the c value. So it's Pythagoras is a squared plus b squared is equal to c squared. So a is half, so half squared. plus b squared, b is also half, is equal to c squared. Half times half is 1/4, so 1/4 plus half is also 1/4 is equal to c squared. Quarter plus a quarter is a half, so 1/2 is equal to c squared. And then we want to find c, so we have to get rid of this square. To get rid of square, we're going to square root it, so we'll square root this. The square root of 1/2 can be written as the square root of 1 over the square root of 2. And then the square and the square root cancel out, so we're left with c. The square root of 1 is 1, and the square root of 2 was we're going to leave this as root 2. So that's our answer to c. So 1 over root 2 is our length, because that's what we're trying to find, the c value, which is 1 over root 2. But in our question, it says to give your answer in the form of root a over 2. So our answer should be root a over 2, where a is a number. But if we look at our answer so far, the surds at the bottom, what you have to do now, guys, is you have to rationalize the denominator. Holy crap, this is a long question. So how do you rationalize this? Rationalize means to get rid of the surd at the denominator, because in our answer, we don't want a surd, so we have to rationalize it. To rationalize a surd, to rationalize a denominator, if the denominator is root 2, we're going to multiply it by itself, root 2. And if we multiply the bottom by root 2, we'll multiply the top by root 2. So 1 times root 2 is root 2. And then root 2 times root 2 is the square root of 2 times the square root of 2 is the square root of 4. And we know the square root of 4 is just going to be 2. So our answer is going to be root 2 over 2. And that is our final answer. The length between a and b is root 2 over 2. Here, guys, are some questions that you are welcome to try. Give it a shot.